Okay, today we're going to be learning about slope fields and a little bit of linear approximation. So, slope fields, also known as directional fields, but for what we do, slope fields, and they're graphical representations of differential equations. They're a visualization of the parallel curves that solve the differential equation without algebra. So it's kind of the visual representation of the differential equation. Okay, a slope field is a field of the slopes. I tell you that, but some people, when they start doing matching like slope fields, they're trying to find the original equation to figure it out. We don't do that. So all we're going to do here is just plot points. So a lot of time in the AP, now they won't give you this many dots, but they'll give you like at most, I think 12 dots is the most I've ever seen. And they would just ask you to plot each slope. Okay, so through all of these dots is going to be a line of some sorts, whether it's perfectly horizontal, or a little bit like a slope of 1, or like a slope of 2, even steeper, or like a slope of 1/2, which is like less steep, including the negatives as well. Okay, so what you're going to do here is you're just going to, I mean, there's a table over here. You don't always need to make a table. Sometimes you can just do this stuff right in your head. Okay, but we'll kind of just go through it. So we're going to graph on all of these, and at some point we could probably figure out a pattern, which usually happens. Okay, so I don't end up doing mathematically all of these. I can figure it out usually, and I'm sure you can as well. Okay, actually my students usually figure it out quicker than I do. So I'm going to start with 0, 0. When I plug in a 0, 0, by the way, there's no y here, which is okay. Alright, there usually is a y, but since there is no y, it's actually going to repeat itself every single y direction, because going up 1 and going down 1 doesn't change anything. Okay, so if I pick 0, 0, what's my slope at 0, 0? So plug in a 0 for x and y. There's just an x. So 0 plus 1 is 1. So I'm just going to graph. That's about as long as I make that line. What about if I plot the point 0, 1? What's my slope at 0, 1? It's 1. Okay, so does the height matter? Why does the height not matter? Because there's no y. So guess what we're going to just do? Just go through. What's another point you want to plot? I don't really care. 1, 0. When I plot 1, 0, what am I going to get? 2. So you just need to graph this steeper than this one previous to it. Now I'm not going to get like my protractor out and be like, oh, that's not quite 2. I want to just make it steeper. Okay, can you visually tell that that's steeper? Let's just go with it. Okay, what's another point we can pick? Negative 1, 0. Sure. What's that negative 1, 0? 0. So it's kind of hard to see, but it's supposed to be my horizontal line. Pick another point. 2, 0. Sure. What's a 2, 0? So make it steeper than that guy. Gets a little bit harder to tell, but again, nobody's been measuring it too much. We're just trying to make sure, okay, is it getting steeper, kind of, sort of? What's another one we can do? 4, 0. 3, 0. Which is going to give us 4, which is actually probably going to be our steepest one. So just, again, I understand how difficult it is to kind of, as long as you're kind of going that direction of it stays steep, you'll be fine. What else can we pick? If you start to see a pattern, just like tell me and we'll stop picking points. So negative 2, 0 is going to give me a negative 1. And then negative 3, 0 is going to give me a negative 2. Hey, what's the pattern from here? I have to fill all these out, right? So do I have to pick out all these points? It's the same thing vertically, because there's no y value, so all of these will be 0. All of these will be a 2. All of these will be a 3. All these will be a 4, which is almost vertical. All these are a -1. All these are a -2. And that's your slope field. Sometimes that's a 1-point question on free response. Just draw the slope field. Okay? Easy 1 point? No. Don't flip it, don't flip it, don't flip it. Because sometimes they'll ask. A common question for a 2nd point would be draw a solution curve through, and let's pick a point here. Let's just do through -1, -1. Okay? That's pretty common, just to draw like what a curve would look like. So you start at -1, -1. So what's the slope at that? 0. And then we're going to kind of just follow through. So what's going to happen as we get further to the right? It's going to increase like that. So you're kind of just following. I usually try to follow the paths through the little lines right there. Usually helps me out. And then the left-hand side would be kind of the same thing. So I'm going to just follow those paths through. Which, by the way, what shape is this? It's a parabola. If you were to solve for this differential equation, guess what you would get? A parabola. But here's the thing. Whenever you solve the differential equations, it's going to give you a plus c. That's why there's so many different ones with these. Okay? So now if the plus c, if we gave you -1, 1, it has a unique solution. So gray is a unique solution. If it gives you 1, 1, all these red lines are just the slopes would be in those directions depending on whatever point they give you. Got it? Do you want to try one on your own?
Yes.
This one has an X and a Y. Go ahead and give it a try. I'll start mine about a minute behind. You do not need to fill out the chart. It's just there for convenience. That's what I got. just walking around to see how we're doing here, so I can yell at you slopes if I need to. Right, so they're super steep. Yeah, that's right. How would you declaration? Kind of like how I did. Really, they only care about, is it 0, is it less than 1, bigger than 1, or is it negative, less than 1, bigger than 1. That's what they really care about so much, so that's all I really focus on. So what I usually do for these is obviously I always start with 0, 0, and I try to kind of sort of find a pattern here. And I notice this is x plus y, that it's gonna, I can find more 0 pairs, right? So like -1, 1, so you give me a 0 pair. Well, you just look for those. So I can kind of figure out, oh, okay, the diagonals are all the same, and that's what ended up happening here. All the diagonals are the same. By the way, this is a differential equation in which you cannot solve. We don't have the, I mean, someone can solve it. We can't. Okay? This is one we cannot solve because of its x plus y. You cannot get dy and dx by itself with just x's and just y's. Well, you can, it's just we don't. There's a formula for it. You learn it in Calc 4. Guess what Calc 4 is called? Differential equations. The whole class on this stuff. DQ. Yeah, diffy Q. Okay, so next part of the notes. Number 3 we're not going to do because it says to match the slope field for the equations, but there's 0 equations here. I don't know where they went. So we'll go on to number 4, because this one does have equations. Okay? So now we're just going to be matching slope fields. This is the multiple choice questions you'll get is, you know, which of the following matches this slope field, or which of these slope fields matches this equation. So it's kind of where we're at. So give you a try on this one, see if you can figure it out. Which ones are which? So just go for it. Got it, Elio?
Yeah, actually.
We'll find out. I'll call on you. If you don't get it, I'll call on Neilish.
I think it's right, but I could be wrong.
Okay. I like the confidence. How much longer do we need? 0 minutes, half a minute, 1 minute, 2 minutes?
How did we go?
So you still want to be here in an hour?
Oh.
10 minutes.
45. What's my next class for you?
Let's just cancel school for the rest of the day and just keep calculus.
Great plan.
Elliot, what'd you get for 15?
15, I got B.
B, boom!
Nice, good boy. B.
What's 17?
B.
Boom! I'm moving it across this way. 16. What do you get? D, boom! And then A, boom! Okay, this is what I do. I'll look at a graph, And like, oh, I find it zeros. Okay, so this is a 0 at 0, 1. I just go ahead and plug it in real quick, see which one gives me a 0. So that's why for A, this is the one that gives me a 0. So find your zeros, usually what I do. If not, I look for, okay, find your positive 1, something that looks like a positive 1. Or even undefined. So right here, there's nothing graphed. If there is nothing graphed there, that means it's undefined. Okay? So if you notice for A, which is right here, why are we undefined all across the x-axis? Because y cannot equal 0. Okay, so that's why. Sometimes some people will graph a vertical line. It's okay. It's accepted. But for questions like these, they don't graph vertical lines. So I just want you to be consistent. Okay. And same thing here. Hey, where's my 0? My 0's at, it looks like, -2. So then I just kind of figured out, okay, where's my at -2? Where do I get my 0? Which is right here. C, I have my 0 at 1, 1, so I just plug in a 1, 1. Where do I get my 0? Now, I can't tell if there's anything at the origin, but after knowing this, yes, there is. And then this is just kind of the leftover one right over here. All right. And if you notice, it repeats itself all the way across. If it repeats itself all the way across, that means there's no x variable. So if you notice, everything's repeating itself across. All right. So, yeah. If everything repeats itself, like, up and down, that means there's no y variable. Alright, so here's a free response question, kind of, sort of. I think they did some of it for you already. So calculator has drawn slope field of dy over dx equals xy is shown in the figure below. The solution curve passing through the point 0, 1 is shown. Sketch 0, 2. Okay, so I kind of showed this for you already. How do we sketch 0, 2? Plot a point at 0, 2. And you kind of just follow the slope field. So going to the right, I'm going up. Going to the left, I'm going up. Kind of sort of like that. So at 0, -1, to the right I'm going down. Left I'm going down. Just follow the slopes. Follow the slopes. I think coming up right here, this is like a free response question that has everything. So I'm pretty sure this is an old AP question because I'm pretty sure I've seen it before. So this is all the parts that they give you. Well, I think it's missing a part, but let's just go through it together. So on the axes provided sketch a slope field. So again, you just have to do it on these parts right here at the 12 points indicated. So you want to do this one together or go solo? Alright, it's like 3 togethers to 2 solos. Together! Okay, part A. So what do I do for part A? By the way, here's my equation right up here. Start plotting points, you all said, right? Okay. So at 0, 0, what's my slope value at 0, 0? I'll write it over here so we can have it. It's 0. Because it's 0 times anything. Okay? What's the next point I want to pick? 0, 1. What happens at 0, 1? Do you see a pattern? What's at 0, 2? 0, 3. Okay. I'm just not going to write 0, 3. Alright. Third of the way there. What's the next point I want to pick? 1, 1? Okay. 1, 0 I heard first. Let's just do 1, 0. Start with the zeros first. So 1, 0, what do I get? -1. 1, 1. 1, 2. 1, 1, 3. Just make sure it's steeper. Negative 1, 0. Negative 1? Yeah, gotta square that X. Negative 1, 1. 0. Negative 1, 2. 1. We're struggling right now. This is relatively simple math. The last one's negative 1, 3, which is going to be 2. So see how this example doesn't have all these like super steep ones? Like that's pretty typical. They don't give you usually ones that are like it's getting like ridiculously steep. This is typical, right? You have your 1s, your 0s, your negative 1s, and your 2s, which is just steeper. Okay. Describe all the points in the xy plane for which the slopes are positive. So when are the slopes positive? So essentially, when the slopes are positive, that's bigger than 0, right? So whenever x squared y minus 1 is bigger than 0. We can do this with an equation, or we can just look at it. Figure it out. So when are all the slopes positive? Two, 3. I heard that. What's 2, 3? What's 2? What's 3? When y is 2? Yeah, but I want all points. You just give me 1 point. You have an infinite amount more points to go. What's y bigger than to make it positive? Y is bigger than? So when y is bigger than 1. Is that true for everything? Because is this positive right here? Okay.
Wait, would it x be greater than 0? Because x is equal to 0.
Well, if x is negative, it doesn't matter because the square is going to make it positive.
Oh, right.
You just can't have x equal 0. And then find a particular solution, y equals f of x to the given differential equation with the initial condition f of 0 equals 3. This is the part that's worth 6 points, and people usually either get 6 or 0. Not a lot of in-betweens. Okay? So I'm just going to rewrite the equation down here. We'll do this together. Okay, what is my first step to solving this? Move things over. I like it. So what are you going to get on the left side? Equals. That's 1 point. People don't do that. People go right to integration and they get 0 points. So that's 1 point. Awesome. What do I do now? Integrate. I'll do it in the gray. On the left hand side, that's actually a baby u sub, which is going to give me an infant u sub. Not bad. Which is going to give me what? ln of. That's 1 point. Equals 1/3 x cubed. That's 1 point. Plus c. That's 1 point. I'm up to 4. I got 4 to 6 so far. Right. So you either do the problem or you don't do the problem.
Oh, well, okay.
So people right away will just go, oh, I'm going to integrate that. And then that's it. It's over. They don't separate the variables.
How do they?
I taught BC kids. They also sometimes forget to do that. When we're in the unit, they don't forget to do it. I would like to reintroduce this problem to you like in a month, and I wonder if you'll do it right. No. Why would I bet you on something that you control? What are you, the Houston Astros?
Yes.
Bunch of jerks. Hey, it's okay. I'm a Red Sox fan, so I'm sure they're a bunch of jerks too. It's not proven yet, though. Okay, so how do I start to solve for y here? So y minus 1 equals what do we do with that plus c? And then plus 1. What's my initial condition? By the way, that's a point. So that's your 5th point out of 6 that you would get. So just plugging in your initial condition. So what is e to the 1/3 times 0 cubed? It's 1. So it's k plus 1. What does k equal? Final answer. Six points. I think this is one of the last problems we're going to do. So we haven't talked about linear approximation yet, so that's the last thing that's going to come up, and we'll just go through this problem. We'll talk about it as we go through. So let f be a function. It gives us an initial condition, and it says the slope is y over x squared. Okay, so it says the slope is y over x squared, which means that this is dy over dx is equal to y over x squared. Okay, so what's the slope now at 1? What am I plugging in? Oh, very good. A 1 for what? What about the y? 3. It says it right up here. So I'm going to plug in, whenever x is 1, y is 3. So 3 over 1 squared, which is 3. The slope is 3. I want you to write an equation of a tangent line at 1, and we're going to use it to approximate. So let's do the tangent line real quick. Remember the equation of a tangent line. Do we have everything? Yeah, we do. So it's y minus this side up here, 3, equals the slope is x minus 1. That's a point. Okay, and then how do we approximate 1.2? What do we do? Plug it in. So what is 1.2 minus 1? What's 0.2 times 3? Add 3 over, you get. it wants you to use this notation, so it's going to be f of 1.2 is approximately 3.6. Okay, so it's really nice. They tell us what the second derivative is in this next question. They're not telling you that. They're asking to find it, which they could. They're being really nice, so say thank you. Yeah, thank you. I don't know who you're saying thank you to, but thank you. Determine the approximation, if the approximation is greater than or less than. Let's talk about how we know something's greater than or less than. Using second derivative, what does second derivative give us? What does second derivative give us in general? Starts with a C. Concavity. Okay? So, this is concave up. We agree. Okay. If I use a line to approximate a value, here's the line. Is that line above or below the graph? It's below. So is that an overestimate or an underestimate? So in this case, it'd be an underestimate because concave up, right? So because, or I'll say it right this way, second derivative is greater than 0. What if this thing was concave down? Yeah, so this would be an overestimate. Okay. I didn't do the problem yet. I'm just showing you the notes to it. So let's do this problem now. So what do I do now to find out if it's an overestimate or underestimate? What do I plug in? Plug in. Okay, we're not plugging in 1.2 because we have to use the points that we used for the line. Okay, because this is the line we got. We plug in 1.2, now we're going to have a different line, and it's going to be not good. So let's plug in what? X equals 1 and y equals 3. Let's do it. So the second derivative. So what do you get?
Wait, 1 minute.
I'm just using this right up here. So it's 1 minus 2 times 1, because x is 1.
Oh, that's times 2.1.
Yeah, times. Here, I'll put a little asterisk. I could have made another asterisk joke, but I didn't. So what do you get? -3? So this is an overestimate or underestimate? So overestimate, it says justify because what do we write down for our justification? What's that, class? The second derivative is less than 0? It's phenomenal. I want a paragraph, Jonah. I don't want that. I just want this. You can write second derivative as negative. That's fine too. I think it's good enough. We good? Or do we want to do another problem? Yeah, we're fine. No different.